Good morning, young friends. Now let us come into our subject manufacturing processes 2 and the module that is ongoing, general purpose machine tools, and topic today is construction, operation and tool layout of semi-automatic and automatic machine tools like lathes. Now the specific instructional objectives of this lesson will be the constructional features and uses of semi-automatic and automatic lathes, kinematic systems and the working principles of commonly used semi-automatic and automatic lathes, processing and tool layout for machining any job in semi-automatic and automatic lathes. Now, why lathes only? Our topic should be automatic and semi-automatic machine tools, but within this limited scope it is really very difficult to cover all these machine tools, automatic and semi-automatic, particularly after such an advancement. And since lathes are most important and most widely used amongst the machine tools, so we shall cover only the semi-automatic and automatic lathes, the knowledge of which can be extrapolated to other machine tools, and you can read also onward from other books. Now the purposes of automation first, which is applicable to any machine tool irrespective of lathe. Purposes of automation in machine tools, these are repetitive production of a job in large volume, that is batch production, lot production, quantity production, mass production, like this. Then high production rate, that is this huge amount or volume of production has to be produced not only large volume, but also very rapidly. But it is a consistent quality of the product, and while manufacturing the quality of the product has to be maintained, and that has to be maintained throughout the volume of production consistently, not this will fluctuate. Then mechanization for minimizing human intervention. So the human involvement has to be minimized, and while minimizing human intervention, we can also reduce the consequences of human intervention, that is mistakes, faults, emotions and exaggerations, all these things. Now types of automation, there are two types of automation. One is called fixed or hard automation, which is conventional and most widely ongoing, where change of the product cannot be accommodated that easily. Whenever the job changes, a lot of change have to be incorporated. Now the modern system is flexible automation. It is very modern. Since 1970 it has been introduced in manufacturing by machine tools, and these are basically CNC based, computer numerical control based, like CNC milling machine, CNC drilling machine, CNC turning machine, machining center and so on. Now the degree of automation, there are different degrees of automation: non-automatic, semi-automatic and automatic. Now what is mean by this? When you machine a job in a machine tool, say lathe, so first of all you have to mount the job, mount the cutting tool, adjust the speed, fit, depth of cut. These are all handling operations, all auxiliary operations which are not directly connected with the chip formation. There is another set of operations which are directly connected with chip formation, machining operations like turning, drilling, boring, facing, centering and so on. The processing operations or machining operations will be obviously automatic, but whether a machine tool will be called automatic or non-automatic, or the degree of automation will be decided to what extent the handling operations or what is called the auxiliary operations like tool mount, job mount, etc. are done automatically or non-automatically. Non-automatic machine tools mean where irrespective of the processing operations, the auxiliary operations are done manually. In automatic machine tools, when not only the processing operations, but also almost all the handling operations or auxiliary operations will also be done automatically, then it will be called automatic machine tool. In between, where say around 50% of the handling operations will be done automatically and 50% say manually, irrespective of processing operations, then it will be called semi-automatic. Now, the classification of general purpose conventional automatic machine tools. As I told you that our discussion will be confined to lathes only, because the scope is very limited. Major classification of automatic, that is fixed automation, which is very conventional type lathes. We are not going to cover to that extent, that is flexible automation, that will be done in some other subjects, or if in any news scope comes. Now, the classification of automatic lathes, one group is called semi-automatic. One group is called semi-automatic. Under them, capstan lathe, turret lathe, multi-spindle vertical turret lathe, coping, that is hydraulic coping lathe. There can be few more, say a relieving lathe, or say multi-tooling lathe, facing lathe. These are also to some extent semi-automatic, if not semi, at least quasi-automatic. Now, automatic type. In automatic lathe group, automatic cutting off lathe, which is not that frequently used or widely used, but single spindle automatic lathe are the most common automatic lathe. Switch type automatic lathe, this will be discussed in detail. Multiple spindle automatic lathe for further increase in productivity. Now, the configuration of semi-automatic lathes. Now, within semi-automatic lathes, the capstan lathe, turret lathe, hydraulic lathe and multi-spindle turret lathe. Now, let us start with the capstan lathe. Here you see the capstan lathe, the configuration is shown over here. This is front view and this is top view. This is plan and this is elevation, and this is the real photographic view of any capstan lathe. Now, this is semi-automatic. Now, very quickly look at it. What is the basic difference or characteristic features of this semi-automatic lathes like capstan turret from say central lathe, non-automatic? This capstan lathe, the turret lathe do not have any tailstock, number one. Instead, there is a turret, hexagonal turret. In this machine, the spindle rotates at high speed for high production and smaller job size. There is a turret which holds number of cutting tools. 6 cutting tools can be held in 6 faces of the turret, which will come forward time to time. The front slide will have 4 tools and the rear slide 1. So many cutting tools can be placed in advance, so that the tools can be selected and put into action very quickly. That will save time. The speed changes will be also done very quickly in this semi-automatic lathes. These are semi-automatic and used for suitably economically viable for batch production or say small lot production. Now, here you can see this is the turret which holds the tool, this is the headstock and this is the saddle or auxiliary bed, and this is a rod, a shaft which is used for stopping, controlling the length of travel of the cutting tools. Now, see the configuration of turret lathe. Now, capstan lathe and turret lathe are slightly different. You see this is capstan lathe, okay, the configuration top view and front view, and this is the true pictorial view, whereas turret lathe, this is the turret lathe pictorial view and these are the front views. So, the schematically they look alike, but practically they are quite different. Now, identify what is the difference. First of all, from this picture you understand that turret lathes are heavy duty, large volume and heavy duty robust lathes, that is number one. Second, in capstan lathe you noted that turret slides, the turret is mounted on a slide and the slide moves on an auxiliary bed which is fixed on the bed an appropriate place, and the length of stroke is small because it is low duty work. Whereas, in turret lathe the turret is mounted on the saddle which directly travels over the bed with a large stroke length. So, this is a heavy duty lathe. Another difference is that in capstan lathe the blank is always bar type, rod like, but in turret lathe it can be rod like as well as chucking type. Here you see that chucking type, the jobs are held in the chuck, unlike capstan lathe. These are heavy duty, but both of capstan lathe and turret lathe are semi-automatic and used for batch production. There is another difference. If you want to cut thread, say external screw thread in capstan lathe, then one die has to be fixed on the front, one of the faces, one die called self opening die. But in case of turret lathe, there will be a lead screw and a half nut engaging which the thread will be cut. So, these are the basic differences between capstan lathe and turret lathe. Here you can see the differences. This is the turret, this is the headstock, and this is the shaft or rod to control the length of the tool travel and so on. What happens? It's not moving. Something wrong. Now, next, this is multi-spindle lathe. Configuration of multiple spindle turret lathe. Actually, why it is multi-spindle? The main purpose is to produce in large quantity and faster rate. So, instead of having only one spindle in lathe, now you will be having 6 spindles, and all the 6 spindles will be engaged for manufacturing say so many pieces at a time. So, this is much more productive. Now, configuration of multi-spindle turret lathes. Distinguishing characteristics of such lathes related to axis. Now, axis of such lathe will be always vertical. Why vertical? If it is vertical, it occupies less floor space. Secondly, it takes the advantage of gravity. And third, loading and unloading of the job is more convenient if the axis of such a large machine tool is vertical. Number of spindles will vary from 4 to 8. With increase in number of spindle, productivity will increase, but not exactly proportionally. If the number of spindle is 8, productivity may be 6 times. Now, the products type. The type, this is chucking type. Mostly you see the chucking type job. So, there were 6 chucks mounted on the 6 spindles. And size, usually the job size is little bigger, larger size. And other thing is, here the products which require lesser amount of, say few machining operations only, say turning, drilling and facing. So, when these number of operations and kind of operations are very simple, only then these multi-spindle lathes are more feasible. But if the job is complex and requiring lot of machining work, then single spindle is better. Now, the classification. Multi-spindle turret lathes are again maybe 3 types. The same the configuration looks alike, but the principle of working will be slightly different depending upon. So, parallel processing. Parallel processing means here this unit, say this unit or say this unit, they looks like one machine tool. So, one spindle, one tool, and one tool will be mounted on the ram. So, this is the ram which along which on the 6 surfaces of the ram the cutting tools are mounted on the slides which move up and down, and there are certain tools which are fitted on this carrier table. This is called carrier table, which can move radially for some work like say grooving, facing, etc., short tapering. Now, in parallel processing, all the 6 pin the carrier disc do not move, as well as the ram also do not move, but only the tools move. So, here all the 6 spindles will be loaded simultaneously by 6 jobs identical, and then it will be started machining. So, in each station you will get only one job, and so at a point of time you will get 6 jobs ready completed, and you unload and load fresh. So, neither these do not rotate. Now, the progressive processing, which is really employed where number of machining operations required is relatively large, say 6 or 8 operations. In that case, suppose this is the loading station. In this loading station, the operator will load a job in this chuck on the spindle, and then this will rotate. So, this job will be carried to the next station where another set of tools are ready to do some machining work. So, the ram will remain fixed, but the tools will move. Then this will go to the next station for few more operations. In this way, all the operations will be completed, and the job will come back to this station and job will be unloaded. In this way, all the spindles will be kept engaged, and you get 6 times productivity. Continuous processing, where both the ram and this carrier rotate simultaneously, and each unit functions as a separate machine tool. Suppose here just 2 machining work has to be done, one say turning and one say grooving. Job is mounted here. After that, this job will move along this path and along this carrier, and while coming to this position, these 2 operations will be complete. Now, when this will be moving like this, the other stations will be also coming slowly, and one by one will be loaded. So, all these things will be continuously done. That is, one job will be done in one chuck on one station only, but the station will move like that. So, all of them will give huge production. Hydraulically driven lathes. Now, in many machine tools, they are hydraulically driven. There are certain advantages or conveniences of hydraulic drive, like this gives a stepless drive. So, the speed and feed can be steplessly varied, operations are smooth and noise free, and self lubricating because of the continuous flow of the lubricant or this hydraulic fluid. But there are certain limitations also for which they are not that popular and not always preferred for especially small machine tools. What are the limitations? It occupies more space, and space is very expensive, leakage problem, and a lot of skill is required for maintenance and repair, because the kind of defect and repair are very complex. Applications. This hydraulic machine tools, especially lathes, they are used for copying type of work or contouring, for producing contoured surfaces. Suppose this kind of job which has got a straight surface, tapered surface, a groove, and then a smooth curved surface. So, this kind of work are done normally in copy turning, hydraulic copying machines or copying lathes. Now, the configuration and use of automatic lathes. So far we discussed semi-automatic. Now, come to automatic, where all the processing operations and the handling operations will be done automatically. Only time to time a long bar or a blank will be fitted from magazine. Now, the distinguished features of this automatic lathes shown over here, the photographic view, are automation. Yes, it is fully automatic, and this is the fixed automation type or hard automation type. There is no computer, no numerical control. Production, it is for use and fast production, that is for mass production or large lot production. Job will be rod like, the bar like, and of small size, say diameter within say 15 millimeter, and length of the job will be around say 10 to 30 millimeter. Speed, see the diameter of the job is small, so the speed will be high, but only few speeds will be available, maybe 4 or 6 speeds will be available, because it is a mass production. So, large number of speeds, spindle speeds are not required as is required in central lathes. Tools. Now, how many tools can be mounted? This is the hexagonal turret where you can mount 6 cutting tools, and there are 5 radially moving or sliding tools. One is the front slide, rear slide, vertical slide, and then 2 inclined. So, 5 cutting tools, 5 plus 6 cutting tools can be mounted of different type. The cost, yes, cost will be obviously high. Now, the switch type automatic lathe. Now, the characteristic features. These machine tools are used. The kinematic diagram will be discussed in more detail later on, but now we discuss the configuration and characteristics and application. These lathes are very small, very tiny, maybe say about say only 6 inch, maybe 2 feet. but they are very fully automatic and highly precision and quite expensive. Now, the characteristics are, now the products are really very small. It is a mass production machine, but the product side is very small, very slender rod like products as you see here are manufactured. The diameter may vary from 2 millimeter to say 10 millimeter maximum, length may vary from 3 millimeter to say 15 millimeter or 20 millimeter. Precision, yes, is a highly precision. The dimensional accuracy and finish will be in the order of microns. Speed, since the diameter is very small, the speed should be very high. Configuration, it has got very peculiar configuration. Number 1, you can see that the headstock travels. Now, if you want to machine turn a rod like this, a long rod, we normally start turning from this side. Now, if we take a long rod, thin long rod projected so much, then there will be a lot of bending force. To avoid that, there is a tool guide, job guide through which the job is passed. This is called job guide, a bush, and the cutting tools are mounted along the guide and the job is gradually projected. So, the projection length or the bending moment will be always small. So, the headstock will gradually move, which will be equivalent to the feed motion. So, this is the unique characteristics of this. So, tool will be almost stationary, moving radially just after this tool job guide, and the job will be moving through that. So, that whatever will be the length of the job, the overhang or the bending moment will be very small. And there will be 5 radial cutting tools shown over here, one say front slide, rear slide, vertical slide and 2 inclined, and these 2 slides will be tool slide will be mounted on a rocker arm, and this rocker arm will be oscillating. When this will move in this direction, this cutting tool will be engaged. When this will rotate in this direction, this tool will be engaged into work. So, this is the basic configuration of switch type automatic. These are basically used for very small tiny components, mechanical components, say these small pins used in say wristwatch or similar things. The configuration and use of automatic cutting of lathe. Yes, automatic cutting of lathe are much less used and common compared to single spindle automatic lathe. These are fully automatic, but very few operations, mainly cutting off or parting the rod into similar rods of similar size. In addition to that, little turning, tapering, facing, centering may be done. This is automatic cutting of lathe. These lathes are very simple and low cost. Multiple spindle automatic lathe, yes, these are again for mass production and a faster production. So, if the number of spindles are large, the productivity will be improved. Now, the major characteristics of this multi-spindle automatic lathe compared to multi-spindle turret lathe are, here in automatic multi-spindle, spindles will be again 4 to 8. Axis, yes, the axis will be horizontal, not vertical like turret lathe. Machining requirements, yes, machining requirements should not be much, say 2 or 3 machine requirements, machining will be required per piece of job. Blank will be bar type, cost will be very high definitely, and application for small ring like or say rod like jobs, for example, say the inner races and outer races of bearings in case of mass production. These are manufactured in multi-spindle lathes, remember. Now, the next is the kinematic systems and working principles of semi-automatic and automatic lathes. Again, we shall remain confined on lathes. Here, this is kinematic system, which is very important for all machine tools, for design purpose and manufacturing. And working principle will depend upon what kind of kinematic system you have adopted. Now, let us start with capstan lathe and turret lathe. As we have already seen that the configuration of capstan lathe and turret lathe, both are semi-automatic lathes, are very similar. Speed and feed drives are very similar. Unlike central lathes, these capstan lathe and turret lathe have got very few speeds and feeds, but those have to be operated manually, but fast with the help of certain mechanisms. So, speed and feed drive are simple, but operated very quickly manually. Bar feed mechanism, yes, because capstan lathe especially and turret lathe also time are used for bar type of work, so say bar stock rod like job, and this rod can be circular section, tubular section, or it can be hexagonal section, hexagonal or square or maybe octagonal, but regular polygon, so that this kind of rod can be held in collets. This is a collet. Okay. Now, the bar feed mechanism, you see, this is the bar which is held in the spindle. This is the spindle, held within the spindle there is a collet. So, this collet holds the job tightly. How? The collet has got a taper end. Against the taper end of the spindle, this collet is pushed by a push tube. This is the push tube. This is the push tube. This push tube is pushed by this taper ring. Now, after working here, so machining is over. Now, the bar has and the job after completion has to be pared and dropped. Now, for the next job, this bar has to be pushed forward, projected from the spindle nose or to the collet. For this bar feed mechanism, bar feed, 4 elementary operations are involved: opening of the collet or loosening of the collet, then push the bar through the collet to appropriate distance or projection, then clamp the collet and return this pushing mechanism. Now, see how it is accomplished. Very simple. First of all, this lever which is manually moved in this direction. As a result, this ring will move in this direction. So, this lever will fall in this direction, this will go back. So, the push force will is withdrawn, the collet will spring back and open. Now, if you move it farther, this is rotated farther, then this end will pull this ratchet in this direction. Along with the ratchet and the pawl, the whole system will be moved forward. Along with that, the jaw will be also moved because it is held by a screw. So, this will be moving, and after it moves to sufficient distance, then this clamp is this tube, this bar is moved in the opposite direction. First, this ratchet goes back freely because this pawl can move freely in this direction, but it cannot move in this direction. So, this will go back, and at the end this ring, taper ring, will go under this roller. As a result, this lever will go up, this lever will go in and push this push tube and tighten the collet. So, this is how the bar feed is accomplished, and this is true for both capstan and turret lathe for bar feeding type. Now, come to the turret indexing. Both capstan and turret lathe are provided with a turret. This is turret which is maybe mostly hexagonal. This is a hexagonal. It can look like a circle, but it can be basically hexagonal. The hexagonal turret, and the tools are mounted on the faces. So, 6 cutting tools, all right. So, this is a turret where the tools is fitted here. Say one cutting tool is fitted here, a tool, and the tool here, say like 6 tools. And after the tool, this is the workpiece. So, after the completion of the work, this turret, this entire turret slide has to be pulled back, and this will be done manually by rotating this pinion against this rack. So, the rack along with this thing will move backward. After coming to the fullest distance, then this has to rotate. This turret, this tool has to go back, and another cutting tool has to come in position for the next job to be done. So, this turret has to be rotated by 1/6 of a revolution if it is a hexagonal turret. It is a hexagonal turret. How this is done? Again, this pinion will be rotated farther in this direction. As a result, this lever, here you can see, here is a lever hinged at the center. At one end it is mounted on the pin, and the other end there is a lever. Now, before this hexagonal turret, this turret is indexed, it has to be loosened. How this will be loosened? It is held tight by a locking pin. This locking pin has to be withdrawn. How this is withdrawn? Now, when it is moved in this direction at the extreme end, this roller will ride on this wedge. This, so see here, this roller will ride along this wedge, all right, and then fall here. When this will ride, this end will come down, along with that the pin will be withdrawn. Now, when the pin is withdrawn, the turret is ready to rotate, free to rotate. Now, when you move it, then there are 6 pins. Now, there are pins. Let me clean it. Now, you can see there are 6 pins mounted here. These are pins, these pins. Now, when it is moved back, one of the pins, this pin will be arrested by this lever. This lever can a little bit oscillate like this. Okay. So, when this pin will be arrested, but you move it in this direction, so this turret will be rotated. This pin will go in this position, and by that time this lever has gone into this position here. So, this end will go up and the pin will fit into the next slot or next hole. So, in this turret, in this surface, there are 6 pin holes like this. So, this turret is indexed and the 1/6 revolution is complete. After that, when you move forward, then this will again, you rotate this pinion by a lever, and then this will go forward, and this roller will come through this big hole just like a T slot. So, the roller will ride on the surface and come through this larger gap provided here as shown here. But how far it will go? Now, when it goes forward, this forward movement can be accomplished either manually or automatically by engaging a clutch. Whatever you do, what will be the length of travel or end of travel? That will be decided by when the screw end will strike here, the stop, this cannot be moved further either manually or automatically. The clutch will open or the person will fill. So, this screw decides the end of travel of the cutting tool. Now, there are many cutting tools which require different length of travel. For different length of travel, different 6 screws are mounted here like this, and when this turret is rotated, then this shaft is also rotated by a pair of bevel gear. Here you see pair of bevel gear, and the bottommost screw corresponds the cutting tool in the front. So, the length of travel of the tool mounted at the front will be decided by the gap between the stop and the screw fitted and the bottom portion. So, 6 screws are there of different position according to the length of travel desired. So, this is how indexing is accomplished. Now, come to hydraulically driven machine tools. Again, you have already heard the advantages and limitations of hydraulic drive. Now, let me show you as an example of hydraulic drive, because in many automatic machine tools hydraulic drives are used, especially heavy duty. Be acquainted with the general circuitry and kinematic system of a particular machine tool. Say, for example, we have taken a drilling machine, drill. This has to go forward to do some drilling operation. This is the motor, this is the gearbox, and this gives the drill rotation. So, speed of rotation is obtained directly from the motor. But what about the feed, that is length of travel and rate of travel? That will be controlled hydraulically. Now, how this will be done? This unit head, drilling head, is clamped to the piston. The piston is here, which is fitted into this cylinder. The cylinder is fixed, and this, in the cylinder there are 2 chambers. Oil is pumped by a pump driven by a motor through a foot valve and screen. So, this one, there is a relief valve to control the pressure. It goes through the direction control valve into this chamber. So, when the pressure rises here and the entrapped oil here goes out through the exit, then this will move forward, feed motion. How long it will go? This will be controlled, the length of travel will be controlled by these stops. There are 2 stops here which will control the location of this pin, okay, this lever which will be connected here or there. Now, these 2 stops will control the reversal of, so this will go forward and will come back depending upon where this ball strikes, here or here. Now, this direction control valve is controlled by, what is direction control valve? Which really hydraulically controls the direction of travel of the piston. Now, this will be controlled by the pilot valve. Pilot valve will be controlled by separately hydraulically by two solenoids. These two solenoids will be actuated by this stop, electromechanical stop, which will control this length of travel as well as the direction of travel. But what about the feed rate? But what about the feed rate? At what rate this will travel? That will be controlled by at what rate this fluid comes out through this channel, flow rate. So, this is the throttle valve. Through this throttle valve, because of the speed of flow, the flow rate will decide through the throttle valve the feed rate. Now, there is a spool which controls the inlet and outlet, that is flow rate. Now, this one is the movement of the spool again controlled by this lever. There is a roller actuated by a cam. So, when this is moving forward first, then this is moving downward, allowing more opening. So, this will go faster. After that, this region will force push it up and the opening will be closed, restricted. So, flow will be slower and the feed will become slow. So, quick traverse and then slow feed, slow back and quick return, all these things are controlled. Now, the feed rate should be controlled irrespective of the force acting on the drill. For that purpose, a special another valve is used called pressure reducing valve. So, this is how all these things are controlled. Now, come to hydraulic coping lathe. Now, the hydraulic lathe are mostly used for contouring purpose, producing the contour, as one example was shown in the handle or lever with a ball and so on, say taper. So, here is a taper to be cut straight, then there can be a cut portion and so on, lot of things. So, this is a hydraulic coping. Hydraulic coping can be done in ordinary lathe also with the use of its attachment, then it will be called hydraulic attachment. But the basic principle is tracer control. Now, I shall explain. Here, this is called template, which is mounted on separately outside, and this shape or profile of the template will be the replica of the job that you want. Suppose it is like this, that means you will get a job like this, So, this end, this portion of the job is the configuration of the template 1:1, all right. And so, there is a stylus. This stylus controls position of the control, this valve, this spool valve, and there is a chamber, there is another chamber. Now, when the high pressure fluid comes through this passage, this enters into, but these two ports are closed. So long this stylus moves along the flat surface, straight axial parallel to the axis of the job, there will be no movement in the stylus. So, these ports will remain closed. So, there will be no oil flow. But when this stylus will, because this screw, this lead screw is rotating constantly. So, the whole saddle moves at a constant speed along with the tool and the stylus. So, when this moves along this slope, suppose it moves from this position to this position, it comes down by a small distance, say delta x, it comes down this stylus. Now, then what will happen? When this spool comes down by a small distance, the ports open. Now, the pressurized oil will come through this port and reach here. So, this will be high pressure and this will be low pressure. Now, because of high pressure, since the piston is fixed, the cylinder will come down. When the cylinder comes down, because of the movement of the stylus, port was opened, because of the movement of the cylinder, the port will closed. As soon as the cylinder also moves by a distance delta x, the port is closed and this movement is stopped. Now, when the cylinder moves down, along with the cylinder, the cutting tool also moves down. So, when this stylus moves by a delta x, the cutting tool also moves by delta x. Then again it is continuously moving down. So, the slope will be like this, it will move like this, it will go like this, come down, go straight, come down, go straight. As a result, effectively this will be a taper surface, and these incremental distances are very small, delta x, delta y. So, it is basically a straight line or maybe a curved line. This is how copying is accomplished. Now, this is looks very complex, but not really that complex. Kinematic system and working principle of single spindle automatic lathe. As I told you that automatic lathes are machine tools are very popular, widely used for mass production, lot production, and lathes are very much more popular and widely used amongst. So, single spindle automatic lathes are most widely used amongst all automatic say machine tools. It is a conventional type of machine tools, general purpose. It is a general purpose. Now, so to utilize or exploit this machine tool to advantage, the workers, operators and designers, manufacturers, everybody should be conversant with the kinematic arrangement of this machine tool. Now, what are the basic features? As I told you, the basic modules of this machine tool. Let us list that first. One is the spindle speed. This is the job, rod like, all right. This is the bar stock shown over here, which has to be rotated, being mounted in the spindle. So, rotation of the job into the spindle, that is one work. Next one is the job has to be fed, that is called bar feeding. So, this rod has to be fed time to time, that is called bar feeding mechanism. Third will be the cutting tools, the rear front cutting slide, rear slide, vertical slide and other 2 inclined slides, 5 slides have to move radially, and they have to be done accomplished by cams, and the cams are mounted on a shaft called camshaft. Okay. And then this turret, next important module is the turret. This turret which holds cutting tools on 6 surfaces have to be indexed, moved forward and backward for the cutting action, and it has to be indexed, and this is the indexing mechanism. Now, let us discuss one by one. First of all, the power comes from this motor to this gears through a gearbox and bell pulley system. Now, as I told you, since it is a mass production machine, single spindle automatic machines or multi-spindle blades, they do not require many speeds, because same job is done with a limited diameter and so on. So, maybe 2 or 4 speeds, this is not very important, but here you can see the speed comes into the shaft number 1, and there are 2 gears loosely mounted on the shaft, and they are connected to 2 more gears on this shaft number 2, and there are 2 sprockets on the 2 shafts, 2 gears, and this from this sprocket speed goes into the 2 sprockets here, which are mounted onto the spindle. But remember, you see that these 2 sprockets are loosely mounted, that is, even if they rotate, the spindle will not rotate. Now, these 2 gears are also loosely mounted. So, these 2 gears will not rotate until the clutch inside, there is a clutch inside. When the clutch is moved leftward or rightward, then either this gear or this gear will be engaged, and this rotation will transmitted to this gear and this gear, which will rotate at the same speed. So, these 2 sprockets loosely mounted on the spindle will keep on rotating at the same speed, magnitude of speed, but in opposite direction. But the spindle will not rotate until the clutch is moved leftward or rightward. So, now again, when this clutch is moved leftward, you get high speed, because the speed is transmitted from big gear to small gear. So, speed of these 2 gears will be high, speed of the spindle will be high, and when this clutch will be engaged with the small gear, this on the right hand side, because of the smaller reduction, the speed of the spindle as well as these sprockets will be low. So, what we understand that by operating this clutch, we change the magnitude of speed. By operating this clutch left or right, we get clockwise or anti-clockwise speed. Now, these clutches are moved forward or backward like this with the help of a lever. The other end is fixed into a cylindrical cam. When the cylindrical cam rotates, this moves here and there. So, this is transferred here. Now, this cylindrical cam has to be rotated by a shaft. Now, before that, let me again tell you that power comes from this motor, goes to this shaft. It also goes to another shaft. This shaft is called auxiliary shaft, which rotates continuously, constantly at 120 rpm. And from this shaft, the power is coming through a gearbox and through reduction mechanism into another shaft called camshaft, which rotates very slowly, and one camshaft rotation means one job. Now, this is how this is done, and this is the shaft is rotated by a single revolution clutch, which transmits rotation only one revolution from this constant speed called this auxiliary shaft to this shaft, only one revolution, and this clutch is actuated by another trip dog, which is mounted on the camshaft. Now, next is bar feed mechanism. In bar feed mechanism, the collet has to be opened. Now, when this push tube, this one is moved in this direction by this lever, this collet will open, the job will be free, and then this lever will move in this direction, push this rod in the forward direction with the help of this finger collet. After that, this will rotate the next half, and this will move in this direction, and the collet will be closed, job will be held tight, and this will move back, keeping the job fixed. This slide will come back by sliding. So, this way this bar feeding is accomplished. Now, come to the turret indexing. The turret indexing. Here, this turret has to be moved forward and backward, that is done by a cam. Why there are 6 lobes? The rotation of speed of this one and this one are same, camshaft and this shaft are same by 1:1, and there are 6 lobes to move this turret, one by one for the 6 cutting tools. So, the configuration of the lobe depends upon the length of travel, rate of travel, direction of travel of the cutting tools. Now, for indexing purpose, this pin has to be withdrawn. That is done. First of all, this shaft has to rotate. When this shaft will rotate, this pin will enter into the slot of the Genova mechanism. So, this will rotate slowly, and before that this pin will be withdrawn, this locking pin. This locking pin will be withdrawn, and so it is free to rotate. Now, this one will be rotated by this pin, and then it will be locked again by this pin. So, this is how turret indexing is accomplished. Now, this is switch type automatic, where this is the bar which is held by a collet here. This is called stationary collet, operated by a push tube. Now, the power comes from the motor through this shaft, and it goes to the spindle. So, the spindle rotates along with the collet and the job in this direction, and then this power comes into this camshaft, which rotates very slowly. Now, when the camshaft rotates, the cylindrical cam moves this entire headstock along with this all these things forward through the tool job guide, the bush, against the cutting tools, all 5 cutting tools, which are actuated by 5 cams or 4 cams, and then which are mounted on the camshaft. And when the job will be complete, then the collet will open, and under gravity the rod will be pushed, it will be arrested by a tool, and again this will be clamped, and this will be repeated. Now, next is process planning and tool layout for machining a job in automatic and semi-automatic lathe. There are certain procedural steps in sequence. Now, what does it mean? That a job has to be machined in large number, say 2000 pieces. So, you have to make a process planning, select the cutting tools, machine tool, and the blank, and then tool layout, all these things. What are the steps? Thorough study of the job to be produced in respect of volume of production, that how many pieces have to be produced, material, size and shape. Shape means circular or regular polygon, size, the diameter, number and types of surfaces to be machined, the amount of work necessary, machining work, required dimensional accuracy and finish, and end use of the product. All these things will help selecting the machine tool, selecting the cutting tools, selecting the blank, and arrangement of the cutting tools and positioning, all these things. Now, selection of the machine tool. This will be in respect of type, what kind of machine tool, automatic, semi-automatic or non-automatic, size, heavy duty, not, precision or non-precision, kind and degree of automation, that is what kind of automation and degree of automation. All these things will be decided by the production requirement, what kind of job, how many pieces are to be produced. Next is selection of blank, that depending on this in respect of material, type, bar, chalking or housing type, preforming should be casting, etc. Then identification and listing of the elementary machining operations to be required. This is the most important part. Suppose here is a job, okay. Now this job has to be done, large number of pieces, and you have to identify what are the machining operations you have to do. Say for example, in this case the facing, chamfering, drilling, then turning, rough turning, then second rough turning, finish turning, this grooving, and then this chamfering, or say partial or initial parting, then thread cutting, then final parting. So all these operations have to be identified irrespective of the sequence. So all these operations have been listed here. This way it has to be listed. Then next step will be combining. This the work has to be combined so that the total time can be reduced. Say for example, facing and chamfering can be done together by one tool. Then chamfering and grooving, this chamfering and this grooving can be done by one tool. Then paralleling, say while doing this rough parting, rough turning, this rough parting and this chamfering can be done simultaneously. Then this rough turning, drilling and centering can be done simultaneously. So this way by overlapping and combining operations you can save lot of time. Now the combining operations, all these things. Now next comes the operation chart has to be produced, process scheduling, a process chart has to be produced containing all the informations that what are the operation sequence, what should be the cutting tool corresponding, what should be the position of the cutting tools and so on. Say tool layout, showing position of the tool layout. For example, if this be the job to be done in a large number, then this will be the corresponding tool layout. Say this is the turret, there are 6 cutting tools, and the front slide may be 2, 3, 4 cutting tools, and the rear slide 1, and there may be vertical tools also. Now, after completing this thorough understanding, you can now do it yourself. Say tool layout, a case study. This is the task. Suppose you have to make 2500 pieces of mild steel bolts of this kind, with all dimensions are given, material is mild steel, number is 2500 pieces. So it is a mass production, very large lot production, so automation is required, and it is a bar type, so single and lot of machining work has to be done, so single spindle automatic is appropriate. So machine tool selected will be single spindle automatic lathe. Blank selected. Now there is a hexagonal head. Now this hexagonal head can be made later on, or if you take a hexagonal bar in advance, then by machining the hexagonal bar you need not machine the hexagonal head, this will automatically obtain. So hot rolled hexagonal mild steel bar of size 14, this is the size, the hexagon is decided by flat to flat, alright, the flat to flat 14. So this way you can do the entire operations, elementary operations you can identify, then you combine the operations as shown over here, then you just write the sequence. Operation number 1, rough turning, initial parting, chamfering together, then rough turning, drilling and centering together, finish turning only alone, spot facing and chamfering here alone, here, grooving and chamfering here together, thread cutting here by a solid die and parting finally alone. Then you prepare this chart showing the position of the tools, say hexagonal turret phase 1, phase 2, phase 3, phase 4, phase 5, phase 6, and the cutting tools like this tools, form tools, rear slide, front slide and vertical slide, and this is the corresponding tool layout. Now, this is where you can practice and you can do lot of exercise with our understanding. Thank you. Good afternoon, young friends. You are welcome to our course Manufacturing Processes 2, the module that is continuing general purpose machine tools, and today's lecture topic is use of various attachments used in machine tools. Now, what are the objectives today? This lesson will enable the students comprehend and state the use of accessories and attachments in machine tools. Second, realize and identify why and when attachments should be used or necessarily used. And third, describe construction and application principles of the various attachments used in center lathes, drilling machines, shaping machines, planing machines and milling machines, which are most conventional general purpose non-automatic machine tools. Now, let us have a quick glance into accessories and attachments. Accessories and attachments both are used in machine tools, but there are differences. What are the differences between accessories and attachments? In respect of use, accessories, remember, these are essentially used for regular work. You know, each machine tool is specified for a range of activities. This is called stipulated work, and for conducting the stipulated activities, some devices, extra devices are to be incorporated into the machine tool. But in the attachments, which are very occasionally used and beyond the stipulation range, you want to, suppose a lathe has got some stipulation, you want to do something which cannot be or should not be done in lathe, but we shall do it in a lathe deliberately with the help of an attachment. This is very occasional. Examples of accessories which are inevitable for regular work: chucks, collets, steady and follower rests, different types of vices, clamps and other things in different machine tools. What about in case of attachments? Say copying in lathes, planing machines. Now, you are doing copying in lathe, milling machine, planing machine with the help of certain attachments as and when required. Thread milling, so you are doing milling in lathe, tapping in drilling machine. So, these are various attachments which are very occasionally used when almost compelled. Ordering.